Hello, I'm Rasmus Benestad, and I will give us a brief demonstration on how to examine or look at data using an R-Shine app called OpenClimateData. And I'll do this with some data we've shared in the Codex flagship pilot study from Southeast Africa. So I'll just share my screen very briefly. Here's my screen. So here is a here's my I have a script here that reads daily data that we've shared from Excel, and I will use this package called ESD here for saving the data in NetCDF. In the NetCDF format. So I'll actually run this script here and I'll explain what it's doing. So here, first we'll read data from Mozambique, and we save the data together with the metadata. So we also keep the longitude, latitude, altitude, and time. And this is for precipitation. So this is the daily precipitation. And any data less than 0 is set to missing or not available, missing value. And then we first generate a time series object using a zoo package, and then afterwards we generate this station object, which is a class that is defined in the ESD package. Then we also add the data from Zimbabwe, a similar way. And then South Africa, similar way as well. And then we add data from Malawi. Here we had slightly different time formats, so we had to alter some of the code in order to make it work. So by reading ASCII data or data from Excel, you often get in their various formats, so you have to spend some time to prepare the data. And here we try to combine them all into the same structure. And then we had from Rwanda, and then we had Rwanda, and combine them all together. And then we only kept data with more than 9,000 valid data points. And then in the end, we saved them as NetCDF. So if we with ls minus lrtb and with substitute nc, we see that we have this here in as a file we generated just right now. So if we move this to open, right. Like that. Then we moved into the data folder of our app called OpenClimateData here. You can also see this is the OpenClimateData. You can see here's the data file set. So there are several data, some from ECCAD and some from METNODI, and one is Southeast Africa. This is the folder that contains our R-Shiny app. It has 3 main scripts: global R, server.R, and UR, and the others are extras. And I have here the 3 principal R scripts for the R-Shine app. When I click on that, you see I get run app in this as an option. So I can run the app here. You can see here it's running. It will start off with, let's do it in English, yes. It will start off with Norwegian data here, but we want Southeast Africa here instead. So here we have the stations we saved here. So we can look at, you can hide this and show this if you want. So let's just hide it now. So here we can show a map of various, both summary statistics, or we can also show the metadata. So you can see here the meters above sea levels. You can see that these are low-lying, these are higher up. we can show like when it started. You see here we can have like a slightly bigger sample size. We can have it even bigger as well. Let's have it go here. We also have range. We can look at a range like in time, so you can filter that a little bit. We can have, so here is just a check latitude. You see that this is latitude and longitude. So we see that the data in the right location. Here's the maximum rainfall. You can see like the maximum is 350. So, and you can see that it has been somewhere here. The average is the default. We can also have a yes with data, so you can see where are the most data. We can highlight the top 10 here. So these are the ones with the longest data sets here. So this one here is the longest one. Or we can also have a low here. The new records is actually more made for the app, and I'll show later, for once we have updated data, so we can update it every day to have up-to-date data as well. So we can have trend, for instance, here is a rainfall trend. We can also show for all year, or we can show for like a particular season instead. So this is in May, April, October, March. So we can get quite a lot of data, show a lot of information on climate here. This is here 10-year return values. We can do top 10 here, for instance. So this is the map that we have. Now we also, if you look here, well, so the default here is Pemba. We'll choose one station as a default. And if you press pathfinder, you will see that this is actually the default. We can choose any here. For instance, Theta here. And we can also do backspace, and we can write anything with A, or we can search for for instance, here, this one here. We can so we start off showing the annual data. We have the total here. We also have the wet day frequency. So it shows the percentage of how many days it rains. So there has been a decline in the number of rainy days from around 29 till 25. You can also hide this trend by clicking on it. We can also look at the wet day mean as well here. So you can see that the intensity has increased. So there have been fewer days, but when we get on the days when it rains more as well. We can also look at the number of rainy days as well. Days with, the here is 20 millimeters. So the predicted one is based on a study, which I will show you later, like reference to, that assumes that the daily rainfall is almost exponentially distributed for the rainy days, and also takes into account a fraction of rainy days as well. Here we can change that to 50, for instance. So then we get an updated plot as well. And you see like there's a fairly good correlation, but it's not perfect. It's just very approximate. If you go back here, we can also go and look at the daily data here, and you can see this is the daily data, and you can zoom in here. You can see that this is the 12th of April 2008, and we got like 244 millimeters this day. And we can out to scale as well if you like. Or you can have monthly data as well. So it's quite flexible. It's a way of looking at stations, but it will only show one station at a time. You can also go in. So this is if we remove this, we can show. So this is somewhere here. If I can also click on Cape Town here, and then it will show the station that I clicked on instead. There's different ways of selecting the stations here. We can also go to the past climate. Here we have, this is like the January, February. So this is like monthly statistics from January to December. So there's a box diagram with whiskers extending to up to 1.5 times the interquartile range here. So this here's the median, and this is the interquartile range in the box here. And then the green and the red are the normal period from 1961 to 1990. We can hide the old one. You see that there's been an increase in the modern period here. And here we also have outliers. We can also look at the daily statistics. So here shows rainfall each day from 1st of January to last of December. And we can also show the individual years here. So then you see that the oldest days are blue, and most recent years are red. We can also, if we double click on this, we can show like individual years as well. You have to be a bit quick. And then we can click on, I can add different ones here to show. But it's better for rainfall to show the accumulated statistics instead. So here you can see how it accumulates over the year, and you can see there's a best spread, and you can see that there's some dry periods as well. We also have other diagrams like year and day. So you can, this is basically shows if you can see if there's like a pattern here. You don't really see much of a rainy season. Let's go here to see if we can find place more with a rainy season. Here, past climate. So here you can see the rainy seasons and dry seasons as well. There's a histogram here. This is for the data presented here, so it's the monthly data, and you can see that it looks like this. If we go for daily data, the histogram changes here, so then we have to zoom in here. Oh, so scale. You can show, or we can go here. We can go on annual data, and we can get this histogram here. We can also look at the spatial statistics that refers to this this map here. So here is a 10-year return value. So and it also says that here. But if we choose, for instance, the trend here, it will update here with a trend instead. So then you can show that. And also here are monthly trends for this station, and it takes a little while before it comes up. So here you have the monthly trends here. So this is January, February, March, and so on. You can see up to December. Now these are upper and lower bounds. So you can see that there have been some strange variations in the monthly trends here. Now, hardly any trends here, but have been some opposite trends in March and April, and then May again. So that this is a bit questionable. And finally, we also have an estimate for the intensity, duration, and frequency curves based on daily data here. In addition, we can explore the data here, so we can look at trends. So here's average and trend. We can look at, for instance, average and maximum here. You can see how they divide. And coloring is according to altitude, and size is according to the years of data. So you can see that most of them have quite similar amount of data here. We can also say look at longitude. we can, if we do maximum, that's okay. Wet latency, we can do number of wet days, and we can do like a maximum, or we can do mean rain intensity, or we can do like say average. You see there's some connection there. Maybe the average is number of wet days. You see that's a better correlation here. Finally, here's actually feedback and about the app. There's some more information. And the engine is the ESD package you can download from GitHub here. And also the app itself is also available from OpenClimateData. The data from Norwegian Meteorological Institute are available on Threads as well. The others are actually not that's available from the app. Once you run it, you can just display it. And here are some papers on the statistics that the app shows. And also, if you have any tips or need any help, you can go to the issues page here. And also, if you have any feedback. I will actually show briefly, like we have the app here also on the web, so it runs on the web. And you can see it's updated now. It was updated yesterday, and also now we can have a look at days with ongoing rain, for instance, and we can have days since last rain as well. So it actually. It's a way of presenting the data that we have on the web as well, that people can see. So that's about it.